Hello everybody, welcome to week 6, differentials and applications. Well, with differentials, once we start doing it, it's actually going to be pretty easy, but there's a little bit of theory to go through. And we start with the idea of slope. So if you have points 2, 7, let's say, and 4, 12, and then find the slope. So you can find the difference of the y's, so subtract the y's. So 12 minus 7. Subtract the two x's, so that's going to be 4 minus 2. So this is going to be 5 over 2. And then notation that I can use to represent that is, on the top I found the difference of the y's, and on the bottom I found the difference of the x's. So that means dy equals 5 and dx equals 2. This is the theory part. So if you go from one point to the next, so this would be 2, 7, this would be 4, 12. And if you go from this point to this point, then you're going to need to go over by 2. Of course, you could just go straight there, but I'm just trying to interpret this. So the dx means in the x direction, go over by 2, so delta x equals 2. And then delta y is 5. Obviously, I did not draw it to scale because 5 should be bigger than 2. It should have gone farther up here. But that's the idea. All right. Next up, we had the definition of the derivative. So there was the limit as x approaches a, and then f of x minus f of a over x minus a. And then when we do the derivative, we can call it y prime, or we call it dy dx. So basically, when you only have this part, when you subtract the y's and subtract the x's, you would still call it delta y over delta x. When you actually take the limit and you find the derivative, then we call it dy over dx. So what's the relationship between dy dx and delta y and delta x? So that deserves a whole new piece of paper. So the idea with the derivative is that you have this function, and then you start with a secant line, so you would go from one point to the next. And as you go from this point to this point, then the distance is delta x. How much did x change? And then you go up to the function, and if this is where we're finding the derivative, then you could make a tangent line right there, and the tangent line would look like this. Trying to draw a nice straight line. And then if you take this idea of delta y and delta x, well, that means as you take this second x point and substitute it in, you would have this is delta x, the same length as down here, and then this is going up, so this is delta y. Once you have the equation of the tangent line, that means that you found the derivative, so you now have dy dx. So the difference between the delta y and the dy is the delta y goes from here to the function. The dy means you took the derivative, so its job is to go all the way up to the tangent line. So see how there's that little tiny extra gap? So that means that delta y is approximately the same as dy. They're not exactly the same because the dy goes from here and it goes all the way up until it hits the red line. So the dy has this little tiny extra bit, but they are very close. And on this picture, the x's did not change, so that means that the delta x is exactly the same as the dx. So the summary is that dy is approximately equal to delta y, and delta x is exactly equal to dx. Then finally, the dy and the dx are called differentials. Which is the point of this week's calculus. All right, then for some examples. So for example number 1, suppose that you have a nice function like y equals x squared minus 9x. And then x1 is going to be a 2, and x2 will be a 4. So if you subtract these two, then we already know what delta x is. So delta x is just 4 minus 2. Delta x equals a 2. And because delta x and dx are always exactly the same, I already know what that one is. It equals 2 also. Now find the dy. So when you take the derivative on this side, you could say y prime, or the other notation for it is you could say dy over dx. They both mean take the derivative. The derivative here is going to be 2x. So the power rule puts the 2 in front, and then you subtract 1 from the exponent, which means it's x to the 1, or just x. And whenever you take the derivative of x just by itself, that's a 1. So this is going to say a negative 9 times a 1. Oh, and by the way, I had this paper with the rules of derivatives, and then I went to the store and bought 3x5 cards. So now I have it on a 3x5 card. And these are the exact same ones as before, although I did add this one, which I just used right here. So if it's a number times x, its derivative will just be the number, because the derivative of x is a 1, so this is just times 1, or in other words, negative 9 times 1. So if it's a number times x, its derivative will just be that number. So I'm going to be using that little 3x5 card instead of the piece of paper. Anyway, now what we need to do is solve for dy. So dx is a number, so I can multiply both sides by dx. These will cancel, and then I would have dy equals 2x minus 9, and then times dx. On the homework, they will be asking for the questions in parts. So at first it will say, what is this as a function? And you just type this in. And then it would say plug in the numbers. So basically you do have to start with the first number. So we're using x equals 2. And when I use dx equals 2, that means it's going to start at 2, and then it's going to change by 2, which is then telling us that 4. So for this one, to finish it up, dy equals 2 times, substitute a 2 for x, and then dx is a 2. And let's see if I can do this without a calculator. So this is going to be 4, and then minus 9, and 4 minus 9 is negative 5, and then times 2, so that equals negative 10. So the dy equals negative 10. Since it's negative, that means the function must be going down, because it's saying the difference in the y's is negative, so that means if we graph it, the function will be going down at that point. Then on to another example. The work is going to be very similar, but example number 2. How about if you have y equals, and then it's an 8x plus 3 gets squared. And first, we're just going to find the dy. So at first, I'm just going to find the derivative, and like with the last one, have dy equals, and then later we'll have numbers to plug in. Well, with this one, we actually need to multiply this out first. Very soon we'll have what's called the chain rule, and then we won't have to multiply it out. But right now we have to multiply it out. And as I've said before, when you have a binomial squared, it's good to use the shortcut, which means you square the first thing, and 8x squared, that makes 64x being squared. For the middle term, you multiply these two, which is going to be 24x, and then you have to double that answer. If you double a 24, it's 48, so there's 48x. And then when you square 3, that's a 9. Okay, that was just the algebra. Now it's time for the calculus. Take the derivative. dy dx. So the 2 goes in front, and 2 times 64 will be 128x. When you have a number times x, the derivative of x is just 1, so you just get the number. And when you have a number sitting all by itself, its derivative is 0. So now just multiply both sides by dx, and we're done with part A. So after these cancel, we just get the differential dy equals 128x plus 48, and then times dx. And then for part B, so find delta x, dx, delta y, and dy over the interval from 1 to 2. The first two are easy. All you need to do is subtract the x's. So delta x just equals 2 minus 1. So delta x equals a 1. And dx is always the same. That one comes for free. Now delta y means subtract the two y values. So we need to take the, well, first of all, the 2, plug it into the original function and see what we get. Then take the 1, plug it into the original function and see what we get, and then subtract those two. So the y value, when I substitute a 2, first of all, is going to be 8 times 2 plus 3 gets squared. And that's going to be some big number. So big, I'm going to use my calculator. So what is 8 times 2 plus 3 if the whole thing gets squared? Oops, there we go, squared. It's 361. Now substitute the 1. So y of 1 will equal, so 8 times 1 plus 3. So that's going to be 8 plus 3 is 11. 11 squared is 121. So there's the two y values, and now just subtract them. So the delta y is just going to be 361 minus 121. So since I already had the 361, I can just say minus a 121. So that's going to be 240. All right, the last part is, so we did this one, and this one, and this one, and now this one. So the dy, well, we have it right here. So we basically just need to plug in the first number, which is a 1, and the dx, which is also a 1. So I think I can even do that right here. So basically just use this part, and then dy will equal a 128, and you always start with the first number. So plug in a 1 for x. And then it said plus 48. And then the dx is a 1, so multiply by 1. And whatever you get for delta y and whatever you get for dy, they should be fairly close. They're not going to be exact, but it should be fairly close. 128 plus 48. Oy, that's not that close. Oh, it's because it's a squared function, which is growing rapidly. And our delta x, in theory, the delta x really should be small, like a 0.1 or 0.01. Since this is a big step, then they actually are off but I typed it in right. Yeah, I typed it in right. That's what it is. So the dy equals 176. Okay, then the next part is the same thing, but with a different type of function. So for example number 3, let's say that the function this time is take a square root of x, and then it gets multiplied with the cube root of x minus 1. And then let's say that, I put it over here, the delta x is equal to a negative 0.5 when the x is a 3. So the delta x can be negative. That just means move to the left. So if you're starting at 3 and you move to the left by a 0.5, that would take you to x is a 2.5. All right, but before we do the numbers, we're going to need to do the derivative. And before we can do the derivative, we need to multiply this out. So this right here, you can rewrite the square root as x to the 1/2. And this one, the cube root, you could rewrite that as x to the 1/3. And so when you distribute and you multiply these two, that means you have to add the exponents. So this is going to be x to the, take a 1/2 plus a 1/3. A 1/2 plus a 1/3. And go to math and have it change that to a fraction. And it's 5/6. So that means its exponent, x is raised to the 5/6. And when I distribute this one over to here, it's just going to be minus x to the 1/2. Okay, now that we've done the algebra, it's time to take the derivative. So dy dx will be, take the 5/6, put it in front and multiply. And then subtract 1 from 5/6. So then if it is 5/6 and we subtract 1 and have the calculator change that to a fraction, the new exponent is negative 1/6. And then for the next one, you put the 1/2 in front and then subtract 1 from this exponent. A 1/2 minus 1 is a negative 1/2. And that's right, you guessed it. The next thing I'm going to say is don't leave any negative exponents. So that means this needs to be moved to the denominator so the 5 can stay on top, the 6 can stay on bottom, but now also move the x to the 1/6 on the bottom of the fraction. And the same thing for this one, the 1 can stay on top, the 2 can stay on bottom, but then the x to the 1/2 gets moved to the bottom. And on this side, I'm going to leave the dy, but then multiply both sides by dx. Okay, so now I found dy dx. The next thing to do is plug in the 3 for the x's and plug in this negative 0.5 for the dx, because if delta x equals that, dx is the same. So dy is going to be 5/6, and then I need to plug in a 3 to the 1/6 power, minus 1/2, and then plug in a 3 for x to the 1/2 power, and then all of that gets multiplied with the negative 0.5. And how much is all of that? So let's see, first of all, I have a 5 divided by, and then I should put parentheses. There's a 6 and parentheses, 3 is raised to the 1/6 power. Then move to the right to get out of the exponent, and now put the parentheses because this first fraction is done. And then minus the next one is 1 divided by parentheses 2 parentheses 3 raised to the 1/2. Then move to the right and put 2 parentheses. And I forgot to put this parenthesis at the beginning and this parenthesis at the end. So I can put the ending one right now, but I need to back up and insert this very first parenthesis. So to do that, you just go second, insert, a parenthesis. And now I have all the parentheses that I need until the very last number, which is this. So then times a negative 0.5. And after all that, it turns out that it's just a nice simple negative 0.20. And then there are some applications. So that's what's coming up next. So for example number 4, suppose that you have a cube. So basically you take a square and then take a copy of this square and then connect the sides. And if I did it, that looks something like a cube. And the sides of the cube are going to be 10 inches and 10 inches and 10 inches. So a cube has sides of 10 inches. So all of the sides are 10 inches. The cube then is covered in plastic. So maybe this is a box and they're going to wrap it up in plastic so it doesn't get damaged during shipping. Is covered in 0.2 inch thick plastic. And then use differentials to estimate the total volume. What's even more interesting when you get into higher level math classes is that this can be a variable, because if you think about plastic, when you stretch it, it's thinner, and when it bunches up, it's thicker. So then this could be a variable, because maybe in a corner it's bunched up and it's thicker, and maybe around the middle it's been stretched out and it's thinner. But that's another calculus class. That's like 3rd semester of calculus. Anyway, find the volume using differentials. So the basic formula for volume is, if we don't know these numbers, we just have to say x and x and x. So the volume is x times x times x, or in other words, x cubed, which is pretty interesting that that's cube and that's cube. Whoa. And then differentials. So just like we were doing, take the derivative. So the derivative with respect to x will be 3x squared using the power rule on the right. And then the dv is going to be 3x squared times dx. And then this is saying what the dx is, and this is saying what the, so this is the dx and this is the x. So this is the 0.2 and this is the 10. So it's going to be 3 times 10 squared, and then dx is a 0.2. And what does that equal? So it's going to be 3, let me clear out that old problem. It's going to be 3 times 10 squared, and then also times a 0.2. So it equals 60. Now this is not the actual volume, because basically if you start with 10 and plug it into the function, so this is the difference in the volume, not the actual volume. So the volume originally, before they coated it with plastic, would be 10 times 10 times 10, or it would be 10 cubed. And then 10 cubed, that's 1,000. 10 raised to the 3, that's 1,000. So what this is basically telling us is that whatever is inside this box, the box itself is taking up 1,000, and the units would be inches cubed. And then the volume of the plastic around the outside is adding an extra 60 cubic inches of volume. So this is how much plastic is being used, and this is how much the actual product is, or the space it's taking up. So then the total would be 1,000 for the inside part plus 60 for the plastic part. So that would be 1,060, and the units are still cubic inches. All right, then another application. So first of all, hopefully you've heard this before, the amount of profit that you can make depends on the amount of money that you bring in. That's called the revenue, minus your costs. So if you were able to have a nice calculator and you were going to manufacture the calculator, or excuse me, you're the manufacturer of the calculator and you want to sell it. So then you could say, all right, we're making $100 per calculator. So that's going to be our revenue, $100 each. And it only cost us $20 to make these things. That means 100 minus 20, they would be making $80 in profit. And then in business applications, they're able to come up with things like this. So this is now example number 5. So what if you know that the cost function is 150 plus 7.5 times x? So in a business situation, what this is saying is it costs $7.50 to make each one of these things. But first we had to buy the machine, which cost us $150. So after we bought the machine at $150, then it can produce these things and they cost $7.50 each. Then their finance department was able to find out their revenue is going to be 3 times x minus 0.02 x squared. So then part A, find the profit function. So profit is just revenue minus cost. So you take this one and then you subtract this one. So the profit function will equal the revenue. So that's 3x minus 0.02 x squared, and then minus the cost of 150 plus 7.5x. And then I should simplify this. And I'm going to put it in order. The squared will go first. So negative 0.02 x squared goes first. And when I distribute this negative over here, that's going to be negative 7.5x, and there's another positive 3x right here. So if you have a negative 7.5x plus a positive 3x, that leaves a negative 4.5x. So then there's negative 4.5x, and then minus 150. So I copied this one from one of the homework questions, and I just, made my own interpretation of it. But this is I'm doing the math correctly, but this is sad because their profit is negative, negative, negative. They are not very good at this business. Okay, so then part B. So then find what is P of 10. So in other words, what would their profit be if they made 10 of these things? So just plug in the 10. So negative 0.02 10 squared minus 4.5 times 10 minus 150 Sorry, I was taking a break trying to see if I missed a negative sign or something, because this is sad. They're going to be losing money. Well, I guess they should have gone into a different business. So let's see. Negative 0.02, and then 10 squared is actually 100. I could do that part. And then minus 4.5 times 10 and minus 150. And so they're losing $197. And then part C, find the marginal profit when x equals 10. And then this is the part that's saying do the differential. So do the differential for the profit. So in other words, right here, we have the profit function, and we just need to take the derivative. So the derivative of p with respect to x equals, so with this one, the 2 goes in front and multiplies, so that's going to make this a 4. So negative 0.04, and then subtract 1 from the exponent, so now it's just an x. And then when it's a number times x, the derivative of x is a 1, so that means we get negative 4.5. And then to solve for dp, so dp equals, and so multiply both sides by this dx, and we have negative 0.04x minus 4.5 gets multiplied with dx. And over here in the directions, I forgot to say and dx. So what if it changes by 1? So substitute a 10 right here and a 1 right there. So dp will equal negative 0.04 times 1. And then what if dx is a 1? So then this is a negative 0.04 times 1 minus of 4.5. And so then negative 454. And then this is in dollars. So basically what it's saying is when they are selling 10 of these things, they're losing $197. And if they increase their production by 1, they're going to be losing an extra $4.54. Sounds like they definitely need to get into a different business. And so usually I do this part in the second video, which I definitely did examples, but I didn't do one like this, so I'll do it right here. So this is the cost function. So it's costing them $50,000 to buy the factory or whatever. And then it's costing them $700 for every auto body frame that they produce. So $50,000 for the machinery, then $700 per auto body frame to make the frame. So find the average cost. Okay, so first find the cost. So that just means plug in a 50. All right, so the cost for 50 auto body frames is going to be 50,000 plus 700 times 50. So that's going to be a lot of money. 50,000, make sure I got all the zeros, okay, plus 700 times 50. And that is $85,000. But then it says, what's the average cost. So you just take the total cost, and then that was for making 50 of them. So just take this and divide by 50. So in other words, C50 divided by 50 is going to be the average cost. So just take the 85,000, divide by 50, and then the average cost. So I already have the 85,000 there. I can just say divide by 50. So the average cost is 1,700. So that's part A. And then part B is find the marginal cost. So the marginal means take the derivative. And basically it has to be the marginal average. So I have to do this in general and then take the derivative. So this was when it was a 50. So in general, the average cost is the C function and then divided by whatever x you have. In this case, it happened to be 50 and we got that number. But in general, it is take this function and then divide that by x. So it's going to be take the function 50,000 plus 700x and then divide that by x. And then that is what we get to take the derivative of. So before I take the derivative of this, I'm going to break this up into two fractions. So when you have one thing on the bottom, you can say it's this divided by x plus this divided by x. So the average cost function now equals, so take 50,000 divided by x plus 700x divided by x. And I'm getting tired of writing this every time, so I'm just going to call it average cost, so AC, not air conditioning, but, sorry, you forgot to tell me that's not on the screen anymore. So instead of average cost, I'll just use AC, which is not air conditioning, it's average cost. And these x's can cancel, so we get 50,000 over x plus 700. And then it's time to take the derivative, and that's where I like to use this one. So when you have 1 over x, the fast way to take the derivative is it's negative 1 over x squared. And whatever number is sitting on top, that number stays on top. It doesn't even change. So the 50,000 can just stay there. So the derivative of the average cost with respect to x equals, and the derivative here will be negative over x squared. And then the 50,000 just stays there. And then the derivative of 700 is 0, so that's just a 0, that's gone. And they were talking about the number 50, so then we need to plug in the 50. So d, and I'm also, or maybe I should do this first, multiply by dx on each side. So negative 50,000 divided by x squared gets multiplied with dx. And then I was talking and not paying attention. That's supposed to say AC. Okay, then in the directions it said to use a 50. So the change in the AC, or the average cost, will be negative 50,000 divided by 50 squared times dx. And then let me see how much that is. So that is negative 50,000 divided by 50 squared. So that's a negative 20. So basically what this is saying is these things only cost $700 a piece, but you have to consider they had to buy the machinery for $50,000. So that gets included in the cost. So basically the cost of making 50 of them is $85,000, or that's $1,700 a piece. Now, of course, if you keep using this machinery to make more and more and more of these things, then your average cost is going to go down, because basically you, in a way, all of these things are then taking this away, or basically you're getting your money back. So if at 50 you were having an average cost of $1,700 and the cost is going to go down over time, how much is it going to go down by? This is saying $20 per unit. And then the last part says, so estimate the average cost for 51 frames. So basically it's then saying if it went from 50 to 51, that means use dx equals 1. And so then that means that the average cost, the difference of the average cost is negative $20. And so like I was just saying, if you at first had an average cost of $1,700 and then you're saving $20, then you've brought the average cost down to $1,680. Okay, so I think that I've actually covered them all. Let me just look. And no, I still need to do one other idea. Okay, so previously we have used the PERT formula. So this is for either populations that are growing exponentially, or they could actually be declining. You can also use this. It could also be money if it's compounded continuously. And the last few examples are about this. In the near future, we'll actually be taking the derivative of this, but this is just basically more practice with this PERT formula and other financial examples. So for the next example, now I don't even remember which I'm on, so I'm just going to call it example. Suppose you have $2,000 invested at 7% compounded continuously. And it's the words compounded continuously that are telling you use this formula. And then how long does it take until the money doubles? How long until it doubles in value? So in other words, we want to take $2,000 and change it into $4,000 without having to drive all the way to Las Vegas and gamble. We'll be safe and put it in the bank. And the bank is nice enough to pay 7%. So don't forget, this needs to be changed to a decimal, so R is going to be 0.07. So take this decimal, move it 2 places to the left, that's the decimal form. How long? That's saying solve for t. And then if it doubles, well, that means that the amount, instead of $2,000, will be $4,000. So substitute the $4,000 over here. The P, excuse me, the P is the $2,000. And then put the E, and the R is 0.07, and then times T. And then solve for T. So you just divide by 2,000 and divide by 2,000. On the right side, these cancel. On the left side, 3 zeros will cancel 3 zeros. And what's left is 4 divided by 2, which is 2. And then The reason that's 2 is because it said double. If this happened to say triple, this would be a 3. So it says 2 equals e to the 0.07t. And then to solve for t, so you next take the natural log of both sides, and these are going to cancel each other. That's the whole job of ln, to cancel out the e, and that means the right side has just 0.07t. And this side has natural log of 2. And all I need to do to solve for t is divide by 0.07 on this side, and then divide by 0.07 on this side. And yes, I would like to use a calculator for the natural log of 2. So don't forget natural log is over here, the one that says ln. So ln of 2 divided by 0.07. And it says that it's going to take 9.9 years. So if you want to double your money in a nice, safe bank account, it's going to take 9.9 years. If you go to Las Vegas and you bet it all, you could double your money in 9.9 seconds. Or you could lose all of your money in 9.9 seconds. Okay, so yes, I did them all, so that's it. We're done.